Hi guys, this is Dr. Juan. I would like to explain a problem, homework problem number 4 in section 2.3. We want to find a general solution for this linear equation. And step number 1 is we want to rewrite this equation into its standard form, which is here the coefficient of the dy dx will be 1, and we need to figure out what the p of x is. And on the right hand side is just a function of x. Now in this case, we need to divide both sides by 1 plus x to make this 1. So step 1, I would like to rewrite. So then I have dy dx minus x over x 1 plus x. I'm going to rewrite it as x plus 1. They're the same. Equals. And if you look at the right hand side, I'll divide this by 1 plus x. If I factor out x, I have x times 1 plus x. So I need to divide by 1 plus x, right? So basically this will be gone. Now, the second step, and by the way, from here, I hope that you recognize the p of x. P of x is equal to negative x over x plus 1. And now I need to integrate this guy to find the integrating factor. So the next step is to find the integrating factor, which is e to the integral of this p of x, which is negative x over x plus 1 dx. So we need to integrate this guy. Now how do I integrate this guy? A little hint. First of all, rewrite this into the following. So look at this. So this x is the same as x plus 1 minus 1. Okay, I just add 1, subtract 1, divided by x plus 1. The reason is I want to split this into two terms, and this is going to be equal to negative 1 plus 1 over x plus 1. Okay, and this x plus 1 over x plus 1 is 1, and I have a negative sign, so negative 1. The next term will be negative 1 over x plus 1, but I have another negative sign, no, it becomes positive sign. Now, of course, if you are not able to make up the plus 1 minus 1, you can always do a long division. So it's just x divided by x plus 1. And you can see that I'm going to add a constant term 0. And this will be 1. So x plus 1. And then you subtract negative 1. So the remainder is negative 1 and 1, right? So therefore, x over x plus 1 will be equal to 1 minus 1 over x plus 1. So that's what this is. That's what this is. Okay. Of course, we have a negative 1. That's why we change the sign. So now I think we should be able to integrate this guy. So this is e to the integral of negative 1 plus 1 over x plus 1 dx. This gives us e to the negative x minus plus ln of absolute value of x plus 1, right? Okay. Now, sometimes we want to simplify our solution, so let's find a region for x so that we can just use ln of x plus 1 without the absolute value sign. Meaning, so if x plus 1 is greater than 0, then we can skip the absolute value sign right there. So this is the same as saying x is greater than negative 1, right? So let's simplify this into the following. So it is equal to e to the negative x plus ln x plus 1. Instead of absolute value of x plus 1, I'll just say x plus 1. This is true when x is greater than negative 1, right? Why? Because in this case, x plus 1 is going to be positive. We don't need the absolute value sign. So this is the domain that I will be using. And let's rewrite this integrating factor as e to the x times e to the ln x plus 1, which is e to the negative x times x plus 1. So this is the integrating factor. Next step, we're going to multiply both sides by this integrating factor mu. So when we say multiply both sides, that means we want to multiply both sides of the equation in standard form, which is this guy. So when we multiply that, we have e to the negative x times x plus 1 dy dx. So look at this one. We multiply both sides by this integrating factor to this equation, okay? So minus e to the negative x plus 1 times x over x plus 1 times y equals the right hand side here, just x times the integrating factor. It will be e to the negative x times x plus 1. Now, obviously, these two will cancel. Now, this left side is always, when you multiply by the integrating factor, it's always going to be the derivative of the integrating factor and the y. That's how we find the integrating factor. So you can always check, find the derivative of this guy. You will see it is this guy. And the right hand side will be just, so I'm going to write this as x squared e to the negative x plus x times e to the negative x. I just expand it, okay? Now, next step, we'll have to integrate both sides, right? Both sides. The left-hand side, the antiderivative of the derivative of this guy will be just itself, okay? Just this guy. And the right-hand side, you have to do evaluate the antiderivative of that and that separately. So I'm going to call this as my 1 and this is my 2. I'll evaluate that on the margin here. So for the second part, okay, when I integrate x e to the negative x dx, integration by parts, I have to do the integration by parts. So in this case, okay, u, let's call u as x, dv as e to the negative x dx, and then du will be dx, right? And v is negative e to the negative x. So just find the antiderivative of this guy, this is your v. So apply the integration by parts. So you have u times v here. Basically, you just do this, u times v. So it's going to be negative x e to the negative x minus v du. So do this, v du, the product of this and this. So which is negative e to the negative x and then dx. And this is equal to negative x e to the negative x. So here this minus, it becomes plus. And the antiderivative of e to the negative x is negative e to the negative x. So this is it. Of course, we have to add the constant c. So this is for the second part. When we integrate the first part, it will introduce another constant c. We don't need two constants c. We just need one c. Just keep that in mind. So therefore, this c, I don't really need it for now. Now let's evaluate the part 1, okay? So part 1, let's evaluate antiderivative of this guy. The reason I evaluate the second part first and then first part, because I know I will take advantage of this result. So now I do the by parts again. So in this case, my u is x squared dv is e to the negative x dx. du will be 2x dx. And my v will be negative e to the negative x. And u times v will be negative x squared e to the negative x minus v du, so multiply these two together, negative e to the negative x, 2x dx, right? So let's rewrite it, negative x squared e to the negative x. So there's a two negative signs. It becomes positive sign. I'm going to take out the 2, move out the 2 to the integral. So it becomes 2 plus 2 times x e to the negative x after I rearrange x and e to the negative x dx. I hope that you recognize this is exactly the same as this guy. So this is the same as this guy. So I'm going to just copy down this answer here to substitute it here. Therefore, I have negative x squared e to the negative x plus 2 times, okay, 2 times. So let's copy this down. Let me just copy it. So I'm going to just copy it, move it down here, right? Okay, I think I'm good. And I just need to plus a c, okay? Now, so I'm going to find the antiderivative. So I'll integrate both sides now. So the left side, the antiderivative of the left side will be just e to the negative x plus 1, y, okay? And on the right hand side equals, antiderivative of this guy is this whole thing, and which is negative x squared e to the negative x minus 2x e to the negative x minus 2 e to the negative x. I think I copied that right, and I kind of multiply the 2 inside, plus the antiderivative of this guy, which is here. So plus the negative x e to the negative x, and then minus e to the negative x. And at the end, I just plus c. I feel like we have a few like terms, like these two are like terms, and these two are like terms. Let's combine them. So in other words, e to the negative x plus 1y equals negative x squared e to the negative x minus 3x e to the negative x, and then also minus 3 e to the negative x plus c. Okay, I think now we just need to solve for y, right? So let's solve for y by dividing both sides this part. And so therefore y is equal to this whole thing divided by e to the negative x, and then x plus 1. Now, I'm going to multiply top and bottom by e to the x, okay? Multiply by e to the x, so that these two multiply to 1. So these two multiply to 1. And so therefore eventually I have x plus 1 on the bottom, and negative x squared. Now e to the negative x times e to the x, that's 1. So I don't write it anymore. Minus 3x minus 3 plus c times e to the x. So I think this is the general solution for the linear equation that we have for this one. And please note that here we do restrict the domain to be x greater than negative 1. So I have to attach that here, x greater than negative 1. So where x is greater than negative 1. All right, this is my hint.